Okay, so the first part, most people did fine on, we're just looking at the periodic table. I'm sorry, the lines got shifted. This one should have been magnesium, which is Mg. Please use a lowercase for the second letter. If you don't, sometimes there are elements that have that letter and then it's confusing about which element you're talking about. Niobium, magnesium in group 2 is a +2. So for the charge, you're going to look at what column it's in. And then for the mass, I think most people got that one. I don't remember what it is off the top of my head. And both of these are metals. They are metals. You know this because they are to the left of our diagonal line. All right, group 15, period 2. Please remember that our first period is hydrogen and helium. So 15 is right here. So it's going to be nitrogen. Even though that looks like it's the first one in its row, there is the period up here that just doesn't have an element there. So this one is nitrogen. And then period 4 is going to be calcium. Okay, so if you missed that one because you forgot about hydrogen and helium, take a mental note of that. Okay, atomic structure. We know inside we have a nucleus, and we are looking at helium. So helium should have 2 protons, and then I'm going to put 2 neutrons. And then the electron should be on the outside. Okay, and then I need to label them, so I can just say the electron is my E negative, the neutron has the 0 in it, and the protons are positive. If you did this, then you've shown me the charges. If you just left the neutrons blank, you didn't tell me what the charges were. 80 protons is going to be Hg, and then we've got this format here, so Z is also 80, and then A is going to be the 80 plus the 116, so that's going to be 196 up here. The charge is going to be protons minus electrons, so 13 minus 10 is plus 3. Let's see. Should put my answer here. But 62.8 times 34 is going to give me 2135.2, but I only have 2 sig figs here, so I'm going to put the 2 1 and then 0 0 and no decimal. Okay, so no decimal shows me that only these first 2 numbers are significant. For this one, how many sig figs do I have? Is the leading 0 significant? No, so only 2 here. So neither of these zeros, they're both leading, is significant, and so I put 4. Let's see, ammonium is C, nitrate is A, hydrogen carbonate is E, acetate is G. That one you can just look at your polyatomic ions. All right, this one people had trouble with. The molecular structure is just counting all the atoms. So I have some B's, there are 2 of them. I have some H's, there are 6 of them. That's the molecular structure. The empirical, molecular formula. The empirical formula is reducing that to the lowest ratio. So since they're both even, BH3 is the empirical formula. Okay. Diphosphorus. So P2, and then hexaoxide, so O6, and then bromine pentafluoride, Br, there's no prefix here, so that means there's just 1, and then fluoride, there's going to be penta, a pentagon has 5 sides, right? And that puts us at the end of our time, so I'll go through the rest of the answers on Wednesday. For the ionic, we have to pay attention to whether or not we need a Roman numeral. So for calcium, it's in group 2, so we don't. We just call this calcium. And then we have fluoride here. And for ionic, we don't use prefixes. There's no di, tri, tetra, anything like that. So it's just calcium chloride. Similar for this, we would say iron chloride, but because it is a transition metal, because it's not a group 1 or 2, we need to tell what the charge is. So since chlorine is -1 and there are 3 of them, then the iron is +3. So I need a Roman numeral, okay? Then going in reverse, calcium is +2, oxide is -2, so those balance very nicely. Tin, here I have a Roman numeral 4. Some of you are looking at that and thinking it's a 5. So IV is 4. Sulfate is a -2, so that means I'm going to need 2 sulfates, SO4, to make that balanced. Okay. For the multiple response, you needed homogeneous. That means it is a clear mixture. So B, if it's cloudy or opaque, it's heterogeneous. If it's pure, then it's not a mixture. 4 sig figs, this number here has the 2's and the 0's that appear after the first 2 are all significant because of this decimal. So these 0's are not significant because there's no decimal, and these 0's are never significant. Okay, so we have D, A, mass numbers equal to protons plus neutrons. B, charge is protons minus electrons. D, 21 electrons. Using the information from above, I'm going to have all of these have a +3. And I'm trying to get to 21 electrons. So what minus 21 is equal to 3? Well, that's 24. So I find element 24, which is chromium. Okay. Dalton's atomic theory about conservation of mass. This came from your quiz. Conservation says it's neither created nor destroyed. So that's D. Molecules in a liquid are not very far apart. That would be a gas. So they're going to be grouped together, but they should be able to move around each other. So with enough room to move around each other is B, which is not diatomic. Argon is a noble gas. So noble gases do not form molecules. All right, for your density, remember density is mass over volume. So I'm going to take my mass, 7.52 grams, and divide by 5.00 milliliters. And let's see, I have my answer key somewhere. That is 1.50 grams per milliliter. Your molar mass is 2 nitrogens and 1 oxygen, which works out to about 44 grams per mole. To find moles, we're going to take 52.36 grams, the amount, divide by grams and multiply by moles. Use this number, 44.02. It goes where grams goes. And we end up with, I have 4 sig figs for both of these, so 1.189 grams per mole. The first concentration is just a matter of moles divided by liters. So I just need to change that to liters, 0.927, and I end up with 0.867 moles per liter. Sometimes it's helpful to have your labels so you know that you're dividing what by what. The concentration, when we have a mass, first we have to change that mass to moles. So I'm going to do divided by 98.9. And then I want to divide that by my 750, but that's in milliliters. So I want divided by 1,000, or multiplied by 1,000 milliliters per liter. And that's going to give me Let's see, I think that's the 0.0342. My answer key got messed up. For this one, we're going in reverse. So we're going to take our 1.50 liters times liters per mole. That's the 1.30. Then we need to go to grams. So we have grams per mole, 98.08. That gives us 191. I'm just going to quickly give you the answers to the last part. And then if you have questions on how to get there, I will show those to you at another time. 74.39%. This is VCl4. The key on this one is divide by smallest moles. That's one you messed up on. And then this one, this is just conservation of mass. If this was my total mass and this was my mass later, then the mass that left is going to be the mass of the water. That's all I was asking. Subtract it. All right. Test corrections are due next Wednesday, so you have a week to do that.
Okay.